All right. So, hi everybody. Welcome to October 14th Building Query Call. Today we're going to be talking about logs and this sort of like general issue of collaboration inside of query. And so hopefully today we're going to just go take some time to present some of the technical side of this. I'm going to quickly add to the chat a link to a gist of some notes that I'm going to talk through. And the main reason for this, we're doing this now, or the reason why we're doing this now, is we have sort of two pull requests around this in the query code base. That will hopefully be landing in the next little while. But in order for Dustin and Casey to be able to properly review this stuff, we need to sort of get the theory behind how logs work and what they're going to do for us under everybody's belt. The actual admit. Oh, people are joining. Hello, everybody. Hello. There. Hey, Rob, how you doing? Yeah, so today we're talking through logs today, which is the sort of like issue of being able to do coordination on today's building query call. Yeah, so I've linked a few things I'm going to link again into the chat just in case anybody didn't have this before. So that's just a gist of notes that is like, they're pretty rough notes, and I'm going to use them as like sort of talking points, but they sort of hopefully will help us cover most of the points. But we're going to talk about logs. Okay, cool. Why don't I share my screen? And I'm going to be screen sharing, so if you want to stop me or ask any questions, just sort of use your mic, because I think that's the easiest way to make sure that I can sort of get to everybody's questions. But yeah, so we've had this issue inside of query. We're building query as I have to mention, this is interesting. I have to admit, hopefully Aaron and Andrew, hopefully you're in and good. But yeah. Yeah.
Andrew's on his way. He's having problems with his Zoom.
Okay. I think we all are these days. Zoom just shipped a thing right now. I have to like explicitly allow people, and it's very irritating. But anyways, so logs. Logs are a primitive that we've written inside of query. We have a pull request pending on some of this. This all needs review. But it's intended to be a foundation for collaboration inside of query, and to do that properly in a sort of decentralized context, we run smack into a whole bunch of problems or some like sort of modern issues of coordination that many of the textile folks have been have been around much longer than we have. And so thank you very much for joining Textile Squad. It's really helpful to sort of get input from people who've been around this problem longer than us. On our side of things, this is really close to a lot of what we're going to talk about today really sort of builds on the notion of a Git ref log. So if you've ever looked at, and that's part of the name for the sort of the inspiration behind the name. But we're trying to do it in a decentralized context. And so there's some slight differences on how that works and how you would need to implement that. We're going to use a couple of new terms today that are new for some. The big one is a log is written as something called a CRDT, which is a conflict-free replicated data type. But the sort of benefit that we're trying to go after is sort of this foundation for all of the collaboration primitives we need in query. And so if we can sort of use the Git metaphor to make things a little easier, Git repositories have names and they have named branches. And so, branches is sort of Git's method for doing collaboration basically at any given point. Every user sort of operates on a branch, maybe on a master branch, but branches are sort of replicated across an object store. And that's how Git does coordination work. And so work happens on branches get synchronized. And then often in Git, the actual object information, so the like data behind the commits, the actual source code itself, the snapshot of the versions, is moved around with as part of the synchronization process. In query, because we have a really very, very different sort of version size of the stuff, we don't have the same sort of luxury where data sets can get really large. And so we don't want to sort of always be moving full data set histories around. And so that sort of pushes a new challenge onto sort of log coordination, where we want to keep logs as small as possible so that there's this kind of like journal of what everybody has done. They form a central point of coordination. But they allow us to sort of point to content address data and say, hey, go get this. So a lot of this Aaron, may sound very familiar to you. This is sort of like externalized. What we're doing to sort of keep logs small and portable is we're pushing as much data as possible out of them. And trying to keep them as concise as possible, because they're the thing that should sort of sync very quickly when you're when you're trying to figure out who did what in any context. To come back to the conflict-free thing, we also need to be able to use logs to get ourselves out of conflicted states. So you can imagine two branches in a Git history that come into conflict. Resolving a merge conflict is a thing that we're going to need to be able to sort of deal with. And we need some foundational sort of like source of truth to understand who has done what and how do we deconflict those kind of things. And that's what the log is. So a log is simply a record of who did what. And yeah, I think we'll kind of get into the sort of specifics of that, of how it works. Any questions so far? This is kind of like a rambling high-level overview, but does anybody need any sort of like guidepost orientation before we get into some of the primitives? No? Okay, cool. So as an overview, our logbooks are sort of structured just to like get a look at some of the code as well. I think it's worth sort of pulling this up. All of the code for this logbook stuff is stored in this logbook folder inside of the query repo. But we've intentionally written the log directory as something that could theoretically be pulled out and sort of generalized upon. So the sort of stuff that's specific to query all lives in this logbook package. And then stuff that is could be used in different contexts is in this log package, which is a sort of much lower level thing. And the stuff we're going to be talking about today is mainly the lower level side of things, this generic set of interfaces. Oh, we've got a new participant request. Hopefully this works. Yeah, so logs are there's basically three things in a log. There's an operation, a log, and a book. An operation, and so those are the three words you're going to hear a bunch. Operations are the smallest unit, and a book is the biggest unit. And then a log is just a ordered collection of operations. For anybody who's read some of the CRDT research, CRDTs generally come in two flavors. And so a conflict-free replicated data type is just a way to replicate data around a whole bunch of peers who want to keep a handle on it. This is part of the decentralization side of things. And there's sort of two flavors. There's either a state-based CRDT or an operation-based CRDT. In a state-based CRDT, you keep pretty much all the information that you want to replicate inside of the thing that you're passing around, inside of the actual data that's being passed around. In an operation-based CRDT, you write down operations that are that need to be performed by everybody to calculate state. So you can sort of imagine it as like, hey, this is a state-based version would just be like a snapshot of a bunch of data, and then another snapshot of a bunch of data. Often they'll use sort of like diffs to sort of modify that data over time to make it smaller. Or you'll do operation-based CRDTs, which are like, I called this function, and then I called this function, and then I called this function, and sort of like, if you played forward by calling all of those functions with these input parameters, you would get the end state that everybody's talking about. But obviously with an operation-based CRDT, you need to know what this function means, and that's often sort of outside of the thing that's passed around. And so for us, our logs are actually an operation-based CRDT. And so it's every log is just a list of, here's what I did. An operation sort of, just to give a look at what an operation, that does not look great in this markdown format. That's tragic. Well, apologies for the formatting, but all ops, this is sort of what an op looks like. And an operation is always just the same set of fields for our purposes. So they're intentionally constrained to be as small as possible. Our latest benchmarks are showing like if you had a single author writing 10,000 events, that would consume somewhere around 2.1 megs of compressed encrypted space on a hard drive. And so being able to do 10,000 events in 2 megs is mainly because you can only use these 8 fields. And obviously you can get really funky, like if this note were to contain 2 megabytes of information, you would completely screw with everything I just said. So putting limits on some of these fields is very important. But all operations contain these sort of basic things, and the things that are really important to them are these top 4 fields. By having an author ID just attributes an operation to an author. That is not repeated every time in an operation, but it is used at initialization. We'll get into that in a second. The name is the human readable name of this log, and that can actually be tracked in a way that we can get into in a second. Method and model are the sort of way of doing multiple things on the same log history. A method sort of just says, it's very similar to an HTTP verb. Like it's like, did I create a model? Did I amend a model, or did I delete a model? And then the model itself is what is the sort of subject of the conversation. In HTTP, this would be the, oh shoot, anyways. You're talking to an endpoint. So basically it's the same as the endpoint type thing. In our universe, this is often like, model is often like user, data set, access control, like it's the name of data models that you're manipulating. These two, ref and previous, are what allow you to create causal histories, and this is kind of the whole point of a log. And so a ref is going to often, in our world, is going to be a reference to immutable content address data. So we can say this operation refers to this external data, and the previous version of this is the previous in the previous field. Relations is intentionally vague. Different operations use this in different ways, and so sometimes that may say that I've created a version, a commit that has multiple parents, and so many parents may be listed here. Or you can say I've published a data set to multiple locations, and the locations could be listed here. And so the actual use of relations, timestamp, size, and note is actually dependent on the type of operation that we're performing. So yeah, that's the biggest, that's the smallest unit that we have. And so almost everything we're talking about is now just connecting together sort of chains of these operations to understand a specific event. And so the way that we get sort of state is by playing forward this, a sequence of these events of the same model type. So if we wanted to understand how many versions of something we would have, we would take every init of a version model type, and we would then get a list of versions. If you played forward inside an operation that was a delete, you would delete one from it, or delete the specified size, which would be potentially a number of commits in causal history. So you can you get this nice property of a log being able to track multiple things. And so if we wanted to say a log is tracking both an access control list and a version history and a naming history, we can do that inside of the same set of operations by delineating them across the model that we're talking about. Does that make sense so far? I'm seeing some quizzical faces. Is this too fast? No? Okay, cool. To sort of close this out, logs are then, not to close this out, but moving on to logs. Logs are just collections of operations. But the thing that I think is interesting on our side that has proven very useful from the API design perspective is logs can be arranged into hierarchies, which we'll get into in a second. But we use this for creating namespaces and branches. So in the query space, the top level is always going to be a username. So you would have a log for a username. And then that log will contain child logs that are names of data sets. And then those logs will contain child logs, which are names of branches. And so to give you sort of how that might look in a sort of very, very abbreviated sense, we would have a book, which is a collection of logs, a user, in this case, which is renamed Amber, and another user, Noor. And then we would have a data set name, and then each one of those comes with a list of operations, and then a data set name, which is, in this case, white wine quality, and the list of operations. In this case, World Bank, we'd have a list of operations. If we wanted to do branches onto white wine quality, they would go underneath this list. And so we would do white wine quality would have another named branch, and that name would come from here. We'll talk about how names are connected to logs in a second. That comes from playing forward the sort of model state of a log. But I think for now, it's just helpful to know that these things are deterministically cached from the actual operations themselves. Everything emerges from playing forward these operations in a list. And then the way peers are, so finally, a book is just a collection of these logs, moving to the highest order thing. Every user's sort of local repository contains a logbook, and that logbook is just every thing that they're storing across every data set, across every branch, across every user that they care about. That book is encrypted at rest, and so the whole thing is stored, encrypted by the user's private key. And every user is identified by their private key. And so whenever we're seeing the words author, or by their hash of public key, whenever we're seeing the word author ID, that is hash of public key. There is a method for, just as there's a way for changing names of stuff, there's also a way of rotating keys. And that's, yeah, again, we'll get into that in a second. Yeah, so books, and then the way we actually do the replication and coordination is a given log will come from a specific user. The user will, I haven't sort of documented this properly here, but it is in the code. When I want to send a log to someone else, I will take out that log. In this example, say it's a log that I've written. I take the log out. I will actually sign the log. There is a section in a log for signature bytes. I'll sign that the signable bytes of that log with my key to say that, hey, I'm the one that sent this. And I will send that along, just the bytes of that log, to someone else. And this is where the CRDT side thing kicks in quite nicely. Since every log is structured as this append-only sort of data structure, I can check what I have on my own log, check to see if the initialization events or the initialization operations are the same. And if the length of the log that I've just received is longer, so if I have the length of my current log is 0 and the one that I just gotten is anything higher than 0, and I trust the person that gave it to me, then I can put it into my logbook, and I now have a synchronized log. By having this sort of like single author, we avoid a lot of the namespace collision problems that would come out of, say, multiple people trying to write to the same thing. That's a lot to stomach, but the point here is like we want merge operations to be really, really, really simple and not have any sort of conflicting issues. And so we're pushing a lot of the issues of coordination and like actual merging of like data set versions or doing any merging logic up and out of the logbook. In this case, we're just writing down who did what and moving that information around as sort of efficiently as possible. Cool. Seeing a lot of confused faces. How does this sound so far? Good. Okay. And I think it sort of helps to just walk through an example here. And this, I think this will hopefully draw things into a sort of more crystalline setup. And we sort of play through these 12 steps of collaboration between two folks, between Noor and Amber. I think it sort of like helps illustrate some of the edge cases that can show up and get to the sort of naming switch thing. In this case, Noor creates a profile. That's going to be this op init profile here. She creates a data set that initializing it to World Bank to just population. She would save a version, amend to that version, so edit that actual version. So this is the exact same as like git commit amend. Create a profile, and then on somewhere else in the world, Amber creates a profile. Amber clones Noor's population, and in that process, they sync logs. And so Amber asks Noor for the entire log for the population data set at that point in time. Gets it from Noor renamed, and then somewhere at some other point, Noor renames her data set to World Bank population, saves another version, and then deletes a version. So she's basically back at square one, or square version 1 amended. And then Amber syncs again. In this case, Amber pulls World Bank population, and then Amber does some stuff that is completely independent of that, just to show that logbooks are storing independent histories in the same book. She initializes the data set name and then renames herself. And so the last bit that we should sort of just cover is the naming situation and how this sort of works and how we keep these synced. It should help also with the sort of key rotation issue. Yeah, names are sort of like an emergent property of an operation set. Basically, I feel like this wasn't covered very well in some of the CRDT literature, but in an operation-based CRDT, if you have recorded all of the arguments that you're passing to an operation consistently, that is itself a state-based CRDT. So by constantly writing down the name field or writing down a name field every time it changes, we have tracked the state of the name argument to something. So by playing forward all of the, in this case, like name models operations, we can track the change of the name over time. And so now we can use the CRDT itself to determine these labels. So these labels are actually cached, right? This renamed author, white wine quality, or to actually get it, you have to play forward every single operation and get the final state of it. But if you needed to sync it and understand it, how do I deconflict these two names? I can look at the first operation of that naming history. And so anything that I have in the situation, the really scary situation shows up here where Noor renames from population to World Bank population. And then Amber has to synchronize to that from what she previously referred to as population and now refers to as World Bank population. And the way we can do that is by being very careful about the first event that we record into an operation, into a log. And so that first event must always have, we call that an initialization operation. And to initialize a log, you have to record a whole bunch of important stuff, which is basically, it has to be of a method of type init. You have to declare the type of model that you are using as the sort of main, the primary model for a given log. You have to declare the author identifier, who is actually doing the work. From that point forward, you actually don't need to record the author identifier ever again unless it changes. And then you have to record a human readable name that is acceptable by external logic rules. As long as you write all those things down, we now have, this forms a sort of a unique foundation for us to compare and deduplicate logs. And so if the name changes at some other point and I want to amend, that would be an amend operation to the main model type of this log. That amend can change author and name, and we can record that forward and understand that that is to be the updated name of something. We can use, again, using external logic to say, oh, you can't change that name to something illegal, or I can use external checks to check if that name's already taken. But the most important thing is I can sort of, if I can pass all of that validation, I can rename stuff and rotate my key because all of that information is recorded as part of the state of the op log itself. Does that register?
Yeah, quick question. Are within query, are the set of models kind of like a static set of possible models just because you're working on like a specific domain here?
Absolutely, absolutely.
Collaborative data science.
Exactly. Okay. And so it's a pretty known thing for us. Like we basically have, and we don't really generate them on the fly, right? And that's where we're like, sort of very external. I can show you the code for that. It's if we look at, hopefully you're okay with reading Go code. These are all the model types that we work on. So it's a user model, a name model, version, which is like a commit, publication model. So like, hey, I published this, I pushed this data set from here to somewhere else. And then an access control model. And so each of these, we actually write them down just as unsigned 32-bit integers, to keep this as small as possible. In the logbook itself, it's, this is effectively an enumeration that is external, but when you write it down, it's just an integer. So for us, it's a very closed domain space, the actual stuff that you're doing. And as an example, like each one of, this is the higher order API that is exposed to other query subsystems, and also sort of serves as a demonstration of how the logbook actually works in practice. But if we look at like writing a version save, so in a typical example, actually here I can pull up the example of this. If we look at logbook test, this sort of like walks through how this would work with a sort of comments and annotations of how each one of these things works together. We actually create a new book with a user B5 and we attach to a file system. And then we sort of initialize a name, which walks through all of this. And then at some point we create a data set. Query is going to have this data set information. And this is like, again, a static thing that's part of our business logic. And then at some point during that save, we're going to say, write version save. And that's going to, under the hood, the logbook thing knows exactly how to interpret data set details and convert that into an operation. Which then allows us to sort of print it back out the other way, where we can say, cool, I want to see all of the, at the end we say, hey, I want to see all of the versions for a given data set reference. I can then use that information to go back into my logbook and pull out the right stuff. And what we'll get is sort of like these two versions. Does that answer the question?
Yep, thank you.
Yeah, this stuff can be pretty dry, but it's definitely keeping everything straight is really, really, really challenging, but I think really worth it. Where we have this, like, to look at the version save under the hood, this is sort of all we're writing down. We're writing down sort of everything we need to initialize a version of a model. But this gives us lots for, yeah, Dustin.
Okay, yeah, two questions. One, so when you're syncing the entire book, not just the logs you have, so that's how you see the rename operation, right?
No, you're syncing just a log, so you can sync a specific log.
How does the rename end up like surviving if you have like a different name for the log down?
Right. So the name of the actual name that when you refer to stuff is a cached thing. And the way that we do synchronization is by comparing the first event in the log, not the last. So the initialization operation has to be unique and is uniquely identifying. So if we look at the like init name, which is like what we do when we create a new, if we type query init, we get a new data set. The init name is going to write down a lot of really important stuff. It's going to say, hey, I'm initializing a name, and I'm this person, and this is the name I want, and here it goes. So we can also use this later for synchronization to say, we don't care what the name is eventually going to be. The way we calculate what a name is eventually going to be is we look at a log name, which is, sorry, name. Let's do this. Oh, come on, name. Yes, so we look at, oh, that's the name of a book. It's really hard to do this when sorry, name. Log, what? Oh, this is old. Shoot, I'll have to show you other code. But
It's fine.
when we actually need to know the name, we just play forward through all of the initialization events. And
you're basically saying sync the log that started with this name, right? And like, I don't care what it's called now.
Yeah, or when it works in reverse, you're basically saying I would like something by this reference, and so if that reference is old, it's going to go look through, and when you pass that in, you pass the initial operation that you're sort of like have, and you have this is what I called it, and I can say cool, I can look for that init operation, and as soon as I have that, I go through the list. We go cool, we have a match. This is what you're looking for.
Is it possible for something else to have been created that then uses that name that was previously used?
That's part of the reason that logs can be arranged into hierarchies, is because then you can write logic that says you can't declare names inside of your own namespace that conflict.
Even if it was renamed away from it.
You can initialize to the same name with a different timestamp if we needed to make them. I don't want to rely on timestamps at all in the system, but if we needed to, we could sort of use that as a way of saying, okay, what's the final state of your current head of names to prevent you from having your tip be inconsistent. That's going to be pretty complicated. For now, we can just say, if you use this name, you can't reuse it.
Okay.
But yeah, that one's going to be one of the nastier parts. The other part that I think is worth confronting here that we have to sort of talk about a little bit, and is sort of part of ongoing research that we haven't talked about, is like a little bit that logs can in fact actually fall into conflict if a user uses the same key pair to write to a log in different places. So this is an example where a user copies their profile to some other machine and then writes, and then it sort of like it works on that data set using that. So they're now using the same key pair, but they're writing to their log in different disparate places. If we tried to sync those, we'd be in sort of weird trouble land. And so we need to sort of like start to think through how that might be dealt with. And I think part of that may actually involve using some of this sort of meta information like timestamps and notes to say something's really confused here and you need to pick which one of these works. The other scary side of that is this could also be happen if the user's key is compromised, right? If somebody were able to download their private key and write stuff that wasn't actually the intent of the actual person tied to that key pair, we would need to figure out a way to rotate their key and sort of get them out of that state. Both of those are scary things that we got to deal with. Yeah. Does that make sense? Yeah, I think if we get away from the scary stuff for a second, what this provides us with is like a pretty nice set of primitives for doing some of this work. Like again, for deconflicting names, we at least have a series of events to sort of deal with. When we want to deal with something like a rebase or something like a merge operation up in version control land where we have two versions of a data set, we now have a nicely laid out set of who has done what. The other thing this does is sort of separate the version history from the way we've been passing around version histories right now is actually just by downloading dataset data and just walking backwards through the tree, right? Each dataset version refers to its previous version in its actual data. The problem there obviously is if you don't have every version locally, then you can't traverse the history, and you can't traverse history past what you know about without some sort of synchronization mechanism. And we've had synchronization mechanisms in the past. This one blows some of them away and just uses something that's a little more dependable. Cool. This is definitely a lot. I'm going to stop screen sharing because I think I saw something in the chat. You do bounce another call? Yeah. Go ahead, Andrew. But yeah, I think the things that are exciting about this system that to me are worth pointing out are just this fact that like you can do the naming stuff and use that, leverage the fact that you have state inside of an operation-based CRDT. I haven't really seen that elsewhere. And I think it forms like a really nice way to do some of this nasty naming stuff. And for us, having human readable names this low in the stack really helps a lot of problems that we've been having elsewhere, where we like the name, people are referring to things by names, and that's often all we have to go on. So like a user tells us, I would like to add this data set. And that's not, it's not like an easy thing to deal with. Yeah. But yeah, thanks so much for joining us, Aaron. If you have any further comments or questions, feel free.
Okay, yeah, thanks. Sorry I got to bounce, but
no worries.
Talk to you later.
Later.
Bye.
But yeah, I've gotten it working locally. We have pretty solid tests around a lot of this, and like a lot of tests around the weird edge casey bits. It's definitely a funky animal to handle, but once we get this handled, we can finally get to a situation where it's very fast to say, hey, this data set changed. You need to get new versions. There are versions of a data set that you don't have. And so that's a simple sort of like log synchronization mechanism. And so we would, the same way you can do git fetch, but git fetch actually grabs all of the source code, you can do query fetch, something like that. And what that would just do is sync the logs instead of the logs in all the data. And we can then write logic that says, hey, you know, I would prefer to just keep the latest version of something, or automatically whenever I see new logs, like pin the newest one, all kinds of fun stuff. But before we can do any of that, we need like a clean, solid foundation for understanding who has done what and when new versions have been created without actually moving all the data itself around. Does that make sense? Rob?
I'm just going to ask some really dumb questions because I felt stupendously confused by everything you just said.
I'm so sorry. This has been hard to get out.
Names and references have nothing to do with each other, and name is your way of creating a set of logs.
Yeah. Names are names for hash linked stuff, and that connection is a business logic thing for us. So they don't have anything to do with each other for the purposes of this discussion.
Okay. It's a little bit confusing because you use the term reference when defining the name, but that has nothing to do with the reference.
Yeah. We'd be better to rename the ref field to path, which is just like, where is that data? Like, what is the path of the external data? And whereas a name refers to something.
Yeah. So I guess the other thing about names that I'm a little bit confused about, it seemed like you were saying this at some point, and I think I was still too confused about what name was doing. Like name is the only sort of reference for the set of logs going together. So how do you handle the case like where you get operations out of order, and you miss a renaming until it comes in later?
Yeah, so we're not, when we talk about synchronization, we're not, and when we talk about CRDTs, it's not like people are passing these around like live every time they write an event. Synchronization is very slow and it's append only. So there's no concern about ordering events because only one author can write events and they only ever append. So there's
okay.
Yeah.
So it's more of an operational transform than a CRDT?
Sort of. It forms a CRDT. The operation log itself is a CRDT. It's a conflict-free replicated data type in the sense that the list of operations is conflict-free and replicatable. Does that make sense?
I mean, maybe my understanding is CRDTs versus OTs is lacking.
Maybe my understanding of operational transforms is lacking. Yeah, that's definitely possible. I've been using the term op-based CRDT as the one specific white paper refers to it. I haven't really researched operational transforms.
Okay. I mean, my understanding was always that the unique and critical thing about CRDTs is that the intent is that you need to be able to receive them out of order, and that's fine. Like that is a defining characteristic of what makes a CRDT special over an OT.
Yes. So you can receive the logs, the total. So a log is kind of the fundamental unit of synchronization. The order in which you receive logs doesn't matter because logs are append only and they're distinct, right? Like, so you're not going to get, it doesn't matter what order you get the logs in. I can go get Dustin's logs, then I can go get Casey's logs, and those two will never conflict.
Okay. And so, I guess this is also where I was getting a little bit stuck on your defining the way these things are nested at different levels. So a data set would never have other logs inside of its log. It would just have operations inside its log.
Yeah, so a data set is just a model that we're talking about in the logbook. It's not actually in it in any sort of like meaningful way other than this is a thing. Its model is type data set and this is its path. So they don't actually contain, the data sets don't contain a hierarchy. The logs do, for naming purposes.
Okay. Yeah, I guess I'm struggling a little bit with the connections there, and I get that because I'm also looking at this, and the thing that jumps out at me, which is fine, but it's the thing that jumps out at me, is that it feels a little bit confusing that in this way of structuring things, the history of what's happened to the data set is not the data set's history, its version history.
Yeah.
And I think I get that that's trying to mirror a world kind of like Git, where you can edit the history, but you don't have to worry about how that syncs for people.
Yeah. That's the hardest thing of this. You have the word history in two different meanings.
Yeah. So it's definitely like, it feels a little bit weird that I have a very explicit set of logs or operations that describe the history of what's happened to this data set. But then there's a separate history that allows me to write a nicer looking history that may or may not reflect what's actually occurred.
Yeah. Dustin.
The analogy here is we have, the ref log in Git, which records the leads in a timestamp, a tombstone sort of way. The difference being that in Git, of course, those aren't replicated in shared other places. So that's the kind of comparison I think makes sense.
Yeah, I mean, like I said, I get it. I think it just is a little bit of a tough concept.
Yeah, it feels really obtuse until you realize the only way Git can figure out that you're on a conflicted branch is it needs some way to tell you that we know what everybody did and we know that this thing is problematic.
Yeah, but I won't get into whether understanding or not understanding Git handles those internals. It's not an important part of this.
But none of this will be service to a user, right? This will be service to a user in the sense that when you type query log, you would see the history populated with dataset data. The thing that really matters is when you type query log, you need to see stuff that you don't have. And that is a huge problem that we have to add this whole meta layer on top to model the behavior, the activities of people in relation to data sets.
Yeah, I guess so. So to go back to my question about when you receive renamings out of order, so you're saying you sync a whole log. I guess this comes back to my what are because it looks to me the way you've written this out, which I think clearly I'm misunderstanding based on what you just said before. It looks to me a lot so you have a logbook that is, I think if I'm understanding right, the logbook is a thing that really only exists on individual clients.
Yeah.
It's not sort of a universal concept. And a log is maybe also of that nature, is not entirely unclear to me.
Yeah.
But the way you wrote out the examples, it feels like different types of objects you have in the system, like a user or a data set, would have logs associated with them.
Well, you would think, you'd think they would be unique, but you kind of, okay. But they aren't because they're kind of all things happening in a namespace, right? It's effectively saying I'm doing stuff inside of the context of a certain namespace. I'm saying under B5/dataset name, I am ostensibly operating on a data set, and to the user, they should just feel like they're operating on a data set. But the user is actually doing a bunch of things that are sort of non-data set related, or that are not just creating versions of stuff that are also participating in that namespace. A classic example is I publish that data set, right? I push this from here to somewhere else. That's really useful information in a decentralized network, is that I can say, oh, I'm going to go look at that other peer for this data because there's a really good chance they have it. That operation is something I did. It's an action I took. It's an operation. And I did it at a specific point in time, and I'm allowed to do it because I'm the owner. I'm query sees me as an owner of that data set. And so the business logic query lets that happen. I write that log. I actually can't receive renames out of order because the entire history, and that's the really tough part of this, is the entire history of the name is completely contained inside of that list of operations. So I started with the name data set, and then as soon as I change, yeah, go ahead.
Okay. But I'm still confused at this point, like what is the meaningful use, I guess, of like the n levels deep namespacing?
Oh, I see.
Like, because your example seems to really show it. Like, I've got like a log for me, and that makes sense. And then I have a log for each of my data sets, which is namespace the same as my data sets. So like, that's, a nice straightforward linkage between those things. I mean, I suppose it seems reasonable that something wouldn't explicitly have to be on the log with the same name as its data set, because they are different universes, and as long as whatever graphs are correct, that's fine. But like then the log, the namespacing doesn't feel like it's doing anything other than providing some nice human organization. But if it's not ever for humans to consume,
why are you doing that? Yeah,
what's going on?
The namespacing helps with confliction, right? So like I need the logs to be arranged in namespaces, and I missed the critical thing here. I should have written this in. When a user creates a data set, it adds to their username operation log that they created a data set of this name, right? What that namespacing affords you is to not have conflicts in the at the like global level, where you have you can sort of say it does help for the arrangement of stuff, but it also means that Noor can create a data set named blah, and that is sort of naturally and is causally linked to Noor's sort of like profile history and abbreviates nicely, right? The amount of operations that are going to be listed or written to the log for data set could be many more. Noor could write a data set that ends up picking a number of collaborators, and that operation log gets quite long. But Noor's profile, like the information about like the sort of more macro level information about what Noor has done in the context of query should be shorter, right? It should just be created a profile, made a data set, deleted a data set, made a data set, made a data set, right? And that's it. And it should be very, very short and very easy. And what that gives you is a really quick way to pass around a list of everything Noor's done. So I can now calculate, the public side of visibility of what Noor's sort of publishing. And then I can arrange those logs into hierarchies to make for faster lookups. So if that list gets really, really, really long, I now know that I need to look for a name model called Noor. And so when you give me something like Noor/dataset name, I know exactly where to look, and I can speed up the play forward of the potential previous history names. So, because you remember, like it can get a little fuzzy where it's like, I'm looking for a data set named blah in Noor's namespace. Those are clues that should help us dramatically scope down the size of the list that we're sort of playing as candidates for a given name. And so by arranging it into hierarchies, we get this really nice sort of like, oh, cool, you're talking about this kind of model. Cool, we can immediately eliminate this many things, because that index can get pretty big over time. Does that make sense?
Yeah, I think that makes sense. And then the other thing you're saying, so that I make sure I'm getting it all together, is that you're never ever passing anything less than a complete log around.
Yes, never ever. Long term maybe, but like the reason we say long term, I mean like if someone writes 100,000 or 200,000 events, maybe, but like we have no reason, if we can store 10,000 events in 2 megs, there's no reason not to send the entire log all the time. And so that's how you'll sync it. We can do optimizations on that, saying, hey, I trust you, and the length of your log is 10,000, and the length of my log is 10,001, so I need to send you one event. We can do that kind of stuff later, but that's only in situations of high trust.
Okay. I guess the thing that still is that sticking point for me is that it seems like because these things are, they're not order undefined and they aren't like a dependency structure, then you still have this, like as soon as you get below the level of a log, like you have a lot of conflicts that are in a thing that a person can never see and so can't really resolve meaningfully. But like, if it's for the far future to figure out how to do that, cool, I guess. I don't know. It's just like, that's the piece that jumped out at me originally, and like it's a little bit assuaged by saying we're never going to pass around anything less than a log, but then if there's a future where we might pass around less than a log, I'm like, oh, okay. I don't know how that's going to work in that future.
Yeah, and I don't think we need to. Like, the whole thing is written so that we don't have to do that. It's like, we should be able to, the log needs to be really, really small, right? It needs to be like as tiny as possible, and we use flat buffers to intern data. So anytime you use the same string, you're only storing that once in a byte buffer. So we shouldn't, small logs that can accumulate easily and be passed around quickly is kind of the reason that we ideally never have to do this, like only send one event. You already have 10,000. The hierarchy arrangement thing is mainly kind of out of like trying to figure out how to work the whole thing in the first place. Trying to understand how we can do the like namespacing branching thing and deal with problems like people trying to claim the same name, which we don't solve here at the top level, but we do, which it's much easier to maintain internally once you have one level deep. So the registry still has to do the username, claiming side of things. But the other side of it, a user's internal namespace should be decentralizable and able to maintain in a consistent sense from that point forward. And it's a lot easier with this sort of like arrangement into these hierarchies.
Okay. I guess the other thing I'm wondering is, and maybe I misunderstood what you were getting at originally, but it sounded like you were saying a big part of what's important about this is for collaboration and coordination. And so so in this may be what generated for me, like my confusion around like passing around things that are smaller than logs or whatever, right? Is the like, that seems like it needs to go to a space where I can take two people's log of all the things that have happened in this data set and shove them together if they're collaborating on a single data set.
That's the part where my brain exploded, and it took a while to realize that that's not what happens, or that's not how we should model the problem. The log, so collaborators on a data set should underneath, so now we have, let's just imagine for a second, we have the username log, we have a data set name log, and then what's that third? The third space is actually what Git calls branches. And for us, I think we can actually start with a simpler model where just every user that is collaborating inside of that data set has their own log. And so that log is a set of operations. And those can't come into conflict because, again, because you can't violate the rule that logs are single author, right? And so if you and I are trying to collaborate on a data set, the issue of creating the version history and the issue of creating the log history are now separate things. I would pull down your data set and do something and say, I propose, I would add an operation that says, combine these two and set the history to this. And we would have to write logic that determines what the canonical reference for a branch, like what the canonical branch is, the same way in Git we have like a master branch. We would have some version of that. And that would have its own operation log that is potentially, that I think is mapped to the owner of the namespace. And so that person's log says, cool, that gets accepted and that gets written and proliferated around. But that might actually be a thing that we have to push out and separately. The point of the logbook is just to write down who wants to do what at what point in time. So now you and I can write dataset versions that may operate in the same namespace, but we can't conflict these because we can write dataset like versions that come into conflict where you and I try to manipulate the same row of a dataset. But you can write your own versions, I can write my own versions. It's offline first, it's asynchronous. And now we can sort of sync our logbooks and say, what did you do? What did I do? Okay, and if we want to try and merge these two things, we now have the primitives to be able to start that conversation, not to actually do the deconfliction of the data set history itself. That has to happen outside.
That's the part I was misunderstanding. Because in most contexts where I've seen CRDTs in use, and I think based on what you're saying, maybe I jumped to a conclusion that part of the point of using CRDTs here was to try and deconflict whatever work I'm doing on a data set with whatever work you're doing on the same data set. But that's a non-goal here.
Yeah, the goal is just to establish who has done what, and then the actual resolution of a conflict of two divergent data set histories is external to this system. It's just Dustin did this, Brendan did this. If you want the data for what Dustin did, it's here. And if you want the data for what Brendan did, it's here. And then some pull request merge button is going to do fancy stuff, but it needs to be fed that information to figure out how to do it in the first place. And we need to know, oh, cool, these two things exist, and we need to be able to check if they're in conflict, and then you can write. And then Dustin's the owner of the namespace, so Dustin writes a new version that says, cool, this is the new version. And we can then sync logs again and say, oh, cool, the master version is deconflicted. That's great. But we need to be able to see what everybody did, and everybody needs to be able to, and that's why we need this sort of like log hierarchy thing, is because we need to be able to say, for us, we only really need 3 levels of depth. We need username, dataset name, branch name. Other applications might want arbitrary depth, and it's just easier if you have only 3 models, and they can be arranged in hierarchies.
Yeah, this makes a little bit more sense now, because I understand that the point of what this was trying to do is not what I had understood it to be trying to do.
It literally took me a month to figure that thing out, like that we're not actually trying to solve dataset version conflicts. We're solving the thing before that.
You're just trying to sync my machine's picture of what you did with your machine's picture of what you did. That's it.
Yeah. And the like nice capacity of you can do whatever you want whenever you want, and I can do whatever I want whenever I want. And that's completely asynchronous. We're just both writing to our own independent op logs or logbooks. And then we can sync them up later, and we can say, cool, I did this, this, and this, and you did this, this, and this. And then we can just pass between our logs.
Yeah. This is really similar to DAP's data model, with the exception of infinite nesting rather than one level.
Totally. The Hyperlog log stuff weighed heavy on this, more than the OrbitDB stuff, I'd say. It's really, really, really close. And it's basically, it feels like the thing that's missing from IPFS that we need to do versioning, right, is this mechanism for synchronizing. We have the advantage of being able to be really opinionated about it and sew in the name problem while we're at it, because we want the name stuff as part of this. And this gives us a nicer home for names and name changes. Awesome. Thank you so much for sitting. Anybody else have questions around this? This is like a big, meaty problem. I've got lots of unit tests around this. I'm feeling better about this, but it's definitely not finished. It'll be a sort of work in progress. We have some stuff that builds on this for syncing logs, and we have a whole bunch of merge stuff in here, but that we didn't cover today. But that's kind of the basics. Questions, comments, concerns, criticisms, foibles? No? Okay. Rob.
Sorry, I just have more questions. So I think if I'm understanding right, we're still saying that sort of like the names used will tend to correspond to names of other existing objects in the system, like me as a user or a data set that I have. Although that's not necessarily like a hard rule, because these are separate trees of things. So I'm still trying to think through, like, so I assume that in that regime, probably like a log would get renamed when the object that log is sort of for gets renamed. And then, but this comes back to, maybe I didn't quite get right when you were saying, like the creation of names. Is it that it's in like the wrong place in this example, like that op belongs to, like, so where like the World Bank population init name op lives should actually be on the user?
No, it's one that's missing. So the logs that are there are accurate, but there's one missing from the hierarchy up that illustrates the purpose of the user's log, namespace log, where you can see the list of data sets they've created. All right, which is, and so I forgot to add the name. If we, yeah, if you were to, here, I'll just share screen really quick because I think that'll.
Newer creates World Bank population, so it has an init name World Bank population in their user ops, and an init name World Bank population in their World Bank population ops, and then they amend the name to world population.
Yep.
But that is only in the World Bank population ops.
Yep.
And then they create they init name World Bank population.
Yeah, the classic problem of like, I've now named this twice. Yeah.
Like that's the part where I'm getting confused.
But your init name World Bank population is a different 0th event, right? I'm now looking for a 0th event that is World Bank population that has, and again, if we had to, we could step back to this, like that I wrote that has this Unix timestamp. And we can now disambiguate names across time. I really don't want to use timestamps for this because I don't think it's the right answer. But we could also say at the other, no, actually we don't need the timestamp because Noor's log has to be the length that it is. You can only append to the log that's the parent. And so you can disambiguate all of this over time, right? If the 8th event that got added is a World Bank population initialization event, then Noor's namespace log is different. So you can disambiguate the origin of names, if that makes sense.
So the thing I'm struggling with at this point is Newer has 3 ops, which is init profile, init name World Bank population, and init name World Bank population. And it has 2, like, if I'm receiving these things, right? So say I sync my log for Newer before the second init name, and I sync my log for World Bank population before the second name, and then I sync my log with Newer again.
Yeah, they need to.
So I have like two init names for the same name that refer to, like, there's a, like, there's 2 init names for the same name, which seems like I've reached an error state now.
Yeah, and so in this case, I'll fall back to the Unix timestamp because I think it's an easier way to illustrate it. I think you can do this with just the length of the logs, but I would have to research that more. But the timestamps would be separate. So imagine you hashed op 0 and the things in both. You could literally you could build a hash map that says the 0th op must match this operation. And so we just look through a list and say, hey, I can pass that around and say, I'm looking for the log that is associated with this origin operation. And if we use Unix timestamps in this case, they will be different. And so they will get different hashes. So even though you're initializing the same name, you are hashing to an operation. The way you're identifying the origin operation of those 2 things is different.
We'll have to talk about this.
Yeah. It's basically comparison of operations can be, you can use as many fields as you need to get uniquely identifying operations. And then you know that it has to be the 0th entry, and that's your sync point.
Okay, but maybe I'm getting confused by the 0th entry part because both logs at this point have the same 0th entry.
No, because the first init name has World Bank population with a Unix timestamp of 5, and the second World Bank population has a Unix timestamp of 6.
Okay.
They hash different things.
I guess what I was trying to say is, like, I know that you're trying to avoid using the timestamp for this because that's hugely problematic. Because if I did it right before and right after daylight savings time ended, too bad. Same timestamp. Yeah. That if you just have all your name related operations in the next level up log instead of just the init name operations, then you've solved this problem.
Then life's easy. Yeah. Yeah. And that might be it. Have to look at it. No, that could definitely end up just being the better way to do it, because then you know that you have the whole history of users namespace in that log.
Yeah. I mean, it also seems to me, but maybe I'm misunderstanding part of this, but it seems to me like all those things to do with name maybe don't even belong in the log with the name. They belong in the log that owns it.
Might be. Yeah. It feels, yeah. I mean, sort of, because the reason you need it in the foundation one is you need to be able to go the other way. So if I do query add v5 / dataset name of tip, right? And I've done a log sync. I want to be able to potentially be able to not have the top level like Noor. I maybe don't care about everything Noor's ever done. And instead, maybe I only care about that name. And I can then ask the logbook for, I'm looking at tip, I'm looking at a name reference, not an origin reference. And that will allow me to say, cool, what is the current, like, latest name of all of these logs? And I can use the entry from in there. So I think that's why we need it down in the bottom level, because that'll let me refer to head.
Okay.
Hopefully we're all right. I mean, so far it looks like it's working, but this is we definitely don't have enough tests on the renaming stuff, and I think this will be that's going to be really interesting to look into. Thank you so much for poking holes. This is I like genuinely appreciated. Like really, Rob, it's really wonderful of you to come out and like try and figure out how this is horribly broken.
I don't know. I've only been looking at it for a few minutes, so.
Super good. Cool. Okay, so I think we'll leave it there. Thank you so much, everybody. Have a lovely rest of Monday, and we'll chat soon.